Hello, guys. Welcome you all to this Python interview series. It's good to see you all back for this series. I had an amazing response for these kind of series videos, so I'm really glad. To be honest, I'm excited to bring you more of these kind of contents. It's not just about interviews. Also about knowing the stuff in detail. It's also about knowing the stuff, you know going a little bit more deeper. So I'm really glad, excited, whatever word you want to fit in. I'm really super excited to bring this to you. So before we jump to the video, who are we are Data Valley, the fastest growing edtech company of 2025. And myself, Franklin, I've been a data engineer for almost 3+ years, and these are all based on the experience of my interviews, and it is also from the people who are regular into these interviews. So these are collection of interviews questions. And talking about this Python series, it's not exactly just about interview questions, but we are trying to keep it more or less like an interview based learning. So those who have been following us regularly, you would be aware about it. So those who are new here, so I just would like to give you an intro. This is an interview based learning. So we'll be progressing from the fundamentals to intermediate level and then to the advanced level. We are just in the fundamental parts though, so you might be a fresher, or you might be mid-level pro, or you could be even a professional, but it doesn't matter. This is a place where you could brush up your skills, and I'm glad to share the knowledge from the industry. So if you're new here, do like the video. If you would like to see more of these kind of content, click the bell icon as well, so that you don't miss on the regular videos. We also publish content in different languages like Telugu and Tamil, so do check out those channels and visit our website at Data Valley, where you will find all about us, what we do, and how we help you with your career. So we have multiple streams of teaching as well, that includes data engineering, data analyst, data science, ethical hacking, Java, Python. So the list goes on. So try to have a check on that, so that you will be benefited out of that. So we have job guaranteed programs as well. So make sure you stay updated in the industry, and how you can ace your next job. So good luck with all your preparations. So without further delay, let's jump to our video. This is our third part of the interview series, and today we are going to cover about everything you need to know about lists. Okay, so as I said earlier, this is all going to be about interview based learning. It's not just interview questions, but you're going to question yourself for each of these concepts and fundamentals, and therefore you get to stay updated, and this will help you in long run. So to start with our first question today, what is a list in Python? Okay, so a list, what is a list? So list is like a fundamental data type or a data structure in Python. Okay, so there are four main data types in Python, or a data structure in Python. Okay, which includes list, dictionary, tuple, and set. Of these four data structures, the most commonly used ones are list and dictionaries. You could be trying into different streams of role, like data analyst, data engineer, data analyst, Python developer. Even all these cases, list and dictionary play a very important role, and it is very much necessary to stay updated on these. So what is a list? We, in our older videos, we repeated about this. We had a talk about those, how list, dictionary, set, and tuple differ to each other. But because we are focusing especially on everything you need to know about lists in Python, And this part is going to come in three different parts. Okay, so everything you need to know about list in Python is going to come out in three videos. So make sure that you check out the other two videos that will be streaming soon. So what is a Python and a list? So list in a Python is a mutable ordered collection of items that can hold elements of different data types. So list is a data structure in a Python which is mutable, ordered, and these can hold elements of different data types. And list in Python is usually defined using square brackets. So as you see here, these lists are denoted by square brackets, whereas in dictionary, you denote it using curly bracket. For a tuple, you use round brackets. So for list, you mainly use square brackets to denote a list. All right? And then, what are the key characteristics of list? Yes, I gave you few terms in the above explaining what is a list, but do you really know the meaning of those terms? That's what we'll be covering in this question. What are the key characteristics of a list? List is ordered. What do I mean by ordered? I refer to the term ordered because the items in the list maintain their position. For example, let's just consider the list here. Okay, so as I said earlier, list is denoted using square brackets, and hence I've used square brackets. And then I have few elements in here, or in this context you can just say items. So I've got one apple, 3.14, true, apple. So I've got five different items or five different elements. And the key characteristic here is that in the order I've inserted the element, the order is going to be well maintained. So this is going to have a position, apple is going to have a position, 3.14 is going to have a position, true is going to have a position, and apple is going to have a position, which is going to be maintained by the list. So that is what I mean by order. And then mutable. What do I mean by mutable? So the very first idea of mutable to me is mutants in X-Men. So why are they called mutants? Because they have altered their gene, right? They have an altered gene within them. So based on that same context, what do I mean by mutables in list? So the mutables in list, they can be amended, they can be altered. So that's what I mean by mutable. So talking in context to a list, you can add an element, you can remove an element, or you can change the element. So for instance, you can replace apple with number 1. So you can replace the item true with another item called 3.14. So that's what I mean by the characteristics of mutability. And then they allow duplicates. What do I mean by duplicates? For instance, a set, which is another data structure in Python, doesn't allow you to have duplicates. Whereas if you consider list, you can have duplicate values. So duplicate is, for instance, if you see in the bottom, you can see that I've got apple, which is a string, and I've got another string, which is an apple. So my list can hold the duplicate value. So that's what I mean by a list would allow duplicates. And then the fourth important characteristic is that it can contain mixed types. So what do I mean by mixed types? Mixed type is when you can have an integer, you can have a string, you can have a float, and you can even have other lists within a list. So you call it a nested list. So you can hold different types of objects in a list. So let's consider this with an example for easy understanding. So I've got a list here called my list. So in this, I've got 1, which is an integer data type, and then I've got apple, which is a string type. Then I've got 3.14, which is a decimal, or in other words, a float. Then I've got true. True or false would signify a Boolean value. And then I've got apple, which is a string again. So as you can see here, my single list can hold a mixed types of elements. So when I print it, you can see that a list gets printed. Okay, and the list is holding the same, different types of elements. And also you can see that those allow for duplicates. The position is maintained. We will talk about mutability later when we work on different functions and operations within list, but I hope you have a better understanding of what is a list and what are its key characteristics. So here in today we are going to talk about few built-in methods and functions that are supported by lists in Python. All right. So what is a built-in method and function? So what do I mean by built-in functions and method is that Python by default will have certain functionalities that will be supported throughout by the data structures. So for all the 4 different data structures that I defined earlier, which are list, dictionary, set, and a tuple, these are going to have inbuilt functions which you can use to run your code or for different functionality. Depending on different use case, you can use these functional codes or methods to make your code work on the process. Okay, before we jump on how to work on different methods and functions, let's talk about how to create a list. So this is our very basic thing, right? How do you create a list? As I said earlier, for a list you need to have a square bracket. So you can see that I've used a square bracket here. Okay, simple. And then it can have multiple different kinds of data types. In here I've got an integer, but let's see how it gets printed. Okay, so if I get this printed, it is giving me a list. Okay, because I've created a list, it is giving me a list. And you can check it by typing in type. So you can give you a variable name, which is my list in my case. It is telling that this is of a list data type. Also, when it comes to string or a text type, you must remember that a string must be always denoted with a quotation mark. Okay, so I'm creating a list again. I'm using square bracket, and remember that this necessarily doesn't have to be my list. It can be any kind of variable. Even you can just name it X. You can just put any name. Let's put data value. Okay, so data value is a name, and I want to input few strings into it. So how do I do it? So I'm using quotation here. So I'm just specifying my name. Franklin is the tutor. So I've got a list that just has string elements. So let me try to print it. So I mean, for collab you can still print it this way, or for a traditional way you can just print it using print bracket data valley, and this is still going to give you, oh sorry, there is a typo, so it's data valley. So when I print it, it's still giving the same list. And for instance, if I check the type of my data valley variable, it is going to say that it is of a list type. So creating a list is very basic. You have to use your square brackets, and then in case of integer, you can just specify the number. That's fine. Same with the float. And if it is of a string type, make sure you use quotation mark, and it'll just get printed anyway. Okay, and you can check your type of your variable by just using type function and then specifying the variable name which has the list object within it. Okay, and then how to append to a list. What do I mean by append? Append is something where you add elements to a list. Okay, append. So you're adding something to the list, isn't it? So how do you do it? So that's my first question. Next to, that's my first question about the built-in functions and lists. So to append, okay, or to add an element to your list, you have to use a functionality call, or a method, whatever you want to name it, a function or a method. So we have to use a function called append function. Okay, to append an item to a list in Python, use the append method. This method adds a single element to the end of the existing list. So what happens when you use an append method? You get to add an element to the end of the existing list. So let's say this is your list. Okay, so I'll show you the syntax as well, just in case. So syntax is, so you have to give your list name, then the append function, and then the iterable. So you have to give your iterable value. So this is the syntax to append an item to your list. So to my existing list, what I'm doing here, so if I print my existing list, you can see that it shows 1 2 3, and now I want to append an element number 4 to my existing list. So what I've done is, this is my list name, so as you can see here, my list, which is my existing list. I'm using dot notation, the append function, and the element I would like to insert. And then when I print it, I can see that, oh sorry, it's reason because I ran the functionality twice. Okay, let me redo it. Okay, so if I run this now, you can see that the element 4 has been added to your existing list. So when I print it, you can see that this shows my list has item 4 added to it, right? And then, okay, I've added a single value to it, which is fine. And let's say now I've got another list. So because another list is it's an iterable item, right? A list is an iterable item. So how can I add this to my list now? Is it possible? If you answered yes, you're more than appreciated. Yes, you're right. You can add to your list. So the process is simple. So here is my new list. Let me show it. So this is my new list. And just in case if you want to check the type, you can. Not necessarily you have to do it, but yeah. So it's of list type, right? So what you're trying to do here, you're going to add a list to a list. So what happens when I try to add a list to a list? Let me print it and have a look. When I print it, you can see that it says that 1 2 3 4 bracket 5 6 7 bracket and a close bracket again. So what has happened here? Each time when I try to run an append function on a list, okay, if it is a single item, it adds to your existing list as an element, right? So you tried adding 4, it's a single element, and it has added to your list as a single element, all right? And now when you try to add a list again, what happens here is that it still gets added as a single item. So as you see here, the list in here, the 5 6 7, so which is a nested list, has been added to your original list as a single item. So there is a difference in how you append using a single item and a list. So is there is a solution to solve this? A solution where you can add elements from a different list to your existing list, but not as a one single component, but as a single individual component, as in 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7. Yes, but we will see about it next. But just remember that if you try to use append with your list, it is going to add your new list to the existing list as a single element. And here are the few points to be remembered. The append method modifies the list in place. So what do I mean by list in place? So your original list 1, 2, 3, 4, when you try to append 4 to it, and when you print the original list, the original list has altered, isn't it? So your original list initially had it only 1 to 3, right? Your original list has only 1 to 3, and if you print it, fine, it shows you 1 to 3. And when I try to append and then print my list, it shows 1 2 3 4 and not 1 2 3. So there is a list in place modification. So that's what I mean by there is a list in place alteration. And it does not return a new list, rather it changes your existing list. And then the append method adds its argument as a single item, even if the argument is another list. So whatever the value that you given to append, it is going to be added as a single item, even it could be a multiple collection of elements within a list. So if you have multiple items in a list which you would like to add to a existing list, it still gets added as a single item rather than individual items unpacked. If you want to add individual elements from an iterable like another list to the end of the current list, use the extend method instead of append function. So I already explained this about you, right? So instead of nested list, I want each element to be placed individually. So how do I do that? I use an extend function. So that is what is our next question about: how to add all elements of a iterable to a list. So extend method differs to our append function in a way that all your elements from a different iterable, which includes list, tuple, set, string, any kind of iterable. So it adds each of those items as an individual element rather than as a whole single item. So the extend method in Python list is used to add all elements from an iterable such as list, tuple, set, or string to the end of the existing list. I believe I've explained you this much better. And as same as append, it modifies the original list in place and it does not return a new list. So what do I mean by list in place? So your original list is going to have the modification, okay? And you're not going to return any new list, okay? Let's see the syntax now. The syntax is say as same as append, where the only keyword has changed. So you're providing a list name and using a dot notation to add your method. So using extend function, and then in the extend function you're going to specify your iterable. So iterable can be anything like a list, a tuple, a set, or a string. Let's see the parameters included for an extend function. So the list name, it's very much needed one, because this specifies to which list you would like to extend these elements to. So make sure that your list name is specified. And then talking about the iterable whose elements will be appended to the list name. So whatever the items you would like to add to this list name, make sure you specify it in the iterable. So to break down its functionality, it iterates and appends. What do I mean by it iterates and appends? The extend method iterates through each element of the provided iterable and appends them individually to the end of listening. So if you see an append function, what happened? No matter what the iterable is, it could be a list, it could be a single element, whatever it can be. What happens? It just adds to the existing list as a single item. But talking about extend, what happens is it iterates through each element. Okay, it goes through each element, and then it adds each of the elements one by one to your existing list. All right. So instead as a single item, what's happening here? It just goes to each element one by one, and at the same time, it's going to add each of the elements that it has iterated by appending them individually to your end of your listening. So, and one more functionality is that you're going to have in place modification as same as append function. So you're not going to return any new list. Unlike concatenation, using the plus operator, ext- sorry, unlike concatenation using the plus operator, extend function modifies the original list directly rather than creating a new list. We will talk about concatenation later, but just remember that a concatenation, when you use a concatenation, you create a new list. Okay? In difference to that, or as same as append function, extend function modifies the original list instead of returning or creating a new list. All right. Now let's see how this can be implemented in the code for your better understanding. So I've got a list here. I've got another list here which has elements 4, 5, 6. I've got a tuple in here. Tuple is represented using round brackets, so 7, comma 8. Those are immutable as well. And I've got a string here. Okay, my string ABC. So what I'm going to do here is I'm going to add each of these iterables. So I've got a list, I've got a tuple, I've got a string. What I'm trying to do here is I'm going to add each of these iterables to my existing list. So let's see how it can be done. First, I'm going to extend with another list. So I'm going to add this element, okay, this list 4, 5, 6. So these individual elements to my original list, okay, which is my original list. So when I try to extend with another list, I mentioned my iterable here, which is another list. And then when I run it, you can see that, oh, sorry, the my list, I didn't run this. That's why it is just picking up the answers from your previous query. Okay. So I've run this code. Now when I try to extend it, you can see that this was my original list 1, 2, 3, 4, 5, 1, 2, 3, right? And here is my another list. So instead of adding them as a single item, in here you can see that those have added as an each individual element. To show you the difference, I'll show you this. Okay, so my list dot append another list, print my list. Okay, let me run this again because there is an in-place modification happening because of extend. So I've made sure that my variables are set now. And when I try to run using append, you can see that it has been added as a single item, 4, 5, 6 as a single item. But next thing you can see that those have been added as an individual element. All right. Okay. Now, how do I extend it using another tuple? Similarly, you just have to change your iterable. So previously you mentioned another list. Okay, you try to extend using another list. Now you are trying to extend using a tuple. So when I try to run this, you can see that it shows me 1, 2, 3, 7, and 8. So you can see that my tuple has been added to my original list. Okay. Now how do I extend with another string? Same. So just replace your iterable with your suitable string name, and when I try to run it, you can see that it shows me 12378 ABC, and you can see that my string has been broken down. So my string was ABC, right? My string was ABC, but in here the string has been broken down as individual elements A, B, and C. So there is an in-place modification as well. So this is how you use your extend functionality with your list. Next one, how is insert different to append and extend? We already briefly saw about the difference between append and extend. Now, how is it different to insert? So insert method in Python allows you to add a single element at a specified position in a list. What do I mean by a specified position within a list? For instance, let's say I have a list here. Okay, let me run this code. So when I run this code, you can see that yes, there is a list. And what do I mean by insert an item or insert the element at a specified position within a list? Before jumping, how to insert, you have to know that how the positioning works in Python list. So talking about positioning, there is a concept called index in Python list. So how indexing works is they start from zero. Okay, they start from zero. In a normal human readable way, how would you uh, you know term the position of an element? You start from one, right? So you call 1 2 3 4 5, so your order starts from one. But talking in context to Python list, your order starts from zero. So in the above list, if you consider this 1 2 6 3 4 5, your index is going to be 1 comma 1 sorry 0 comma 1 comma 2 comma 3 comma 4 and 5. So 1, the position of 1 is 0, position of 2 is 1, position of 6 is 2, position of 3 is 3, position of 4 is 4, and position of 5 is 5. Okay, so I mean, just to avoid confusion, maybe I'll add one more element here. So let's just put it at 7. So in this case, 0 represents 1, position 1 indicates 2, 2 represents 6, 3 indicates 7, 4 represents 3, position 5 denotes 4, and position 6 denotes the element 5. Alright, so this is how your indexing work. It starts from 0. Okay, so what's happening here? What did I say? An insert method in Python allows you to add an element at a specific position within a list. So what you have to do is you have to specify the position based on your index. For instance, I want you to add an element to the position 4. So what do I mean by position 4 here? So 0, 1, 2, 3, and 4. So my new element is going to get added up here, right? So you have to use your index to add your element. This method differs from append, which adds elements only to the end of the list, and extend, which adds multiple elements from another iterable to the end of the list. So how is it different to append and extend? So in append, you get to add an element only at the end of your list, right? But in extend, you get to add your element at your specified index position. Okay, how is it different to extend then? In extend, it adds multiple elements from another iterable to the end of the list. So even with extend, though it can add multiple elements from another iterable, it still adds to the end of the list. But with insert, it just adds to the specified position. Let's have a look at the syntax. The syntax is you specify your list name and then you use dot notation to include your insert method. It can take up to two parameters, so an index parameter and an element parameter. So this index parameter, what does it indicate? It represents the position where the element should be inserted. So for in our case, let's say I want to insert number 1 at position 0. So if I'm trying to add an element at here, so my new element at 0 should be, I mean, let's say I want to insert number 9 at position 0. So it is going to get added up here. All right. So you specify the position. So you need to use index for that. And then you gotta specify the element. So what is the element you would like to insert at that particular position? You have to specify it. So these both are the parameters, and these both parameters are necessary parameters, so these are not optional, and make sure that you have it specified. So let's break down how it functions. So when an insert method is called, the specified element is placed at the given index. So whatever the element you're trying to insert, it gets added to your specified position. At the same time, when it gets added, all the existing elements from that index onwards are shifted one position to the right to accommodate the new element. For instance, in our above case, okay, now there should be index up to 7 because we have got 8 elements here. Okay, let's say I want to insert an element at position 5. Okay, what is the element at 5 now? 0, 1, 2, 3, 4, and 5. So 3 is currently at position 5. So I want to insert an element A at position 5. So what happens if I'm inserting A here? Okay, if I'm inserting A here, this is going to get the index 5. And what happens next? This index is going to be 6, and the index of this is going to be 7. All right, so 0, 1, 2, 3, 4, 5. What was our previous element at 5? It was 3, right? So this position is altered, so now it is going to get position 6, and 4 is going to get the index 7, and the element 5 is going to get the index 8. So that is how your insert functionality works, because whenever the elements get added, the elements onwards, what do I mean by onwards? The element afterwards, that position, they get a new positional index. Also, when an element gets added, the length of the list gets increased. Isn't it obvious? Because in this we initially had like 5, I mean 6 elements, so position of 5, and now I've included more elements. Therefore my index has extended to 8. If my index is increasing, what does it denote? It denotes that the length of the list also extends. So it has increased. So now my elements, I mean, now my list is holding up to 9 elements. So length of my current list is 9. So as you insert new elements, the length of your list gets increased. Let's take an example below. I'm creating a new list with 3 elements: apple, banana, and cherry. And now what I want to do is I want to insert a fruit called orange at index 1. So based on the indexing, what is the index position for the above? So what is the index position for the above? So that should be 0 for banana, sorry, 0 for apple, 1 for banana, and 2 for cherry. So this is our current index position. And now I want to insert orange at 1. So what happens here? So 0, 1. So I'm going to replace banana with orange, and therefore banana is going to get a new index 2, and cherry is going to get a new position called 3. So that is going to be our new index. Now let's see how our list looks like. Oh, as you see here, you've got apple, orange, banana, and cherry. And you can see that orange has been inserted at position 1. And also you can try to understand that there was an in place modification. Hence when you try to print your list, it gives you a modified list with the element orange added to it. Okay, now let me try to insert a new element, a fruit element at index 0. So what should be my index 0? So where is my index 0? So index 0 is, where is it? It's Apple currently, right? So I mean, this is our list anyway, this is our current list. So if you consider in this example, we have got four index, so 0, 1, 2, and 3, each corresponding to each element. If I'm trying to insert grape, what happens here? Grape gets inserted before apple because apple is at 0. And what happens to your existing elements? The positional index gets added. So apple becomes 1, orange becomes 2, banana becomes 3, cherry becomes 4, and grape gets the positional index 0. Let's see how it is in our code now. As you see here, the index has been changed and the length of your list has increased as well. Okay, now let's talk about a different scenario. Okay, let's say you are trying to insert an element which is beyond the current length of your list. What do I mean by current length? So the current length of my list is that, so what is my current length? 0. So I've got 5 elements. So the length of my current list is 5. Now what I want to do is I want to insert an element that is beyond the length of my current length. Okay. So what happens is when I try to insert it, it gets added no matter what the position I specify. Okay. So I've added this to my end of the list. Okay. Which is fine. But let's say in this case, so I've got grape, apple, orange, banana, and code. So what are the positional indexes for the above? So the current index positions are 0, comma 1, comma 2, comma 3, comma 4. How many elements have I got? Grape 1, 2, 3, 4, 5, 6. So the positional index stays up to 5. Okay, this is my current index position. What I'm going to do here is I want to insert an element at an index beyond what my list can hold. So there is only 6 elements, right? And 5 positional index. What I'm planning to do is I want to insert an element at the position 10, which is not existing in our current list. So currently it has only index up to 5. So what will happen if I'm trying to insert an element beyond the length? What happens is the element just gets added to the end of your list. Okay, so you don't have to worry that it'll get inserted beyond or after the position, or what would happen if the current position doesn't exist. If the current index doesn't exist, it just gets added to the end of your list. All right, so this is all about your insert functionality. And then how do you remove an element from the list? So we have seen how to add elements to your list. Now let's see how to remove the elements from your list. Okay, so to remove the element from your list, you use a remove method. Okay, so the remove method in list is used to delete the first occurrence of a specified value from the list. Okay, just a sec, let me correct the window size. Oh, so whenever the first occurrence of the element comes, that particular element is removed. What do I mean by the first occurrence of a specified value? Let's say your list is having duplicate values. So if you see in our very first example, which had duplicates, isn't it? We had 2 apples. So if you see this, we have got duplicate values within our list. So I've got 2 apples. So if I try to remove a value from here, okay, let's specify apple. So what gets removed? So the very first occurrence of the element. So would it be apple or would it be the apple at position 1. So apple at 1 or apple at 4. Talking about the very first occurrence, so it should be apple at position 1. All right. So that's what the remove function does. So what are the key characteristics of remove method? It removes by value. What do I mean by it removes by value? So unlike pop, so do not worry about pop. I will explain that further. But just remember that a pop function removes the element based on index. So what is the functionality you use to add your element based on index? So append, you just add the element at the end. Extend, it just adds your element at the end. So you use insert to element at a specified position. Similarly, pop is a function which removes the element based on index. But unlike pop, what does an remove do? It just removes the element at the very first occurrence. So remove function requires the actual value of the element you want to delete as an argument. So pop removes by index and remove removes it based on the value of the element. So for a pop, let's say you just specify the index as 2. So whatever the element is at the position at 2, it's going to get deleted. But whereas if you consider remove, you have to specify the elements that you would like to remove. For example, in our case, we had apple. So I have to specify the value apple, which in turn will delete the element. So talking about remove, it removes the very first occurrence. So if the specified value appears multiple times in the list, remove function will only delete the first instance it encounters. So I explained you nice with the apple example, right? So you had apple at position 1 and at 4. But it doesn't matter. It is going to remove the elements from the position 1 because that is the first occurrence. Okay. Let's say you are trying to remove a value which is not specified or which is not included in your list. In that case, it will raise an value error. So if your value is not present in the list, you get to raise an value error. So what happens in a value error? You break the code because an error has been raised. So make sure that you specify the element that is included in your list to be removed. Also, this is an in-place modification. So a remove function is going to alter your original list. So okay, and rather than creating a new list, or it doesn't, create an updated list. It just removes your original list. So make sure that uh, you're very sure about what elements to be removed as it is removing the elements from your original list. Talking about the syntax is more or less similar to other methods. You specify a list name, you specify a remove function with the dot notation, and then you say what elements to be removed. So that's what is meant by value. So whatever the elements you would like to remove, specify it in your code. So here I've got a list called my list. So I'm printing it to check. So it has got 10, 20, 30, 20, and 40. So first what I'm trying to do here is I'm going to remove the element 20. So would it erase this or would it remove this? If you have listened it very good, you know that it is going to remove this element because that's the very first occurrence of that particular element. So if I try to remove this, and if I print my list, you can see that 10 is there, 20 is removed, 30 is present, 20 is present. So 20 is not, removed. It is still in my list. And 40 is still present. So it has removed the element 20. And next use case, I want to I want to remove an element which is not existing in my list. So what did I say? If you try to remove an element which is not existing in your list, it will raise an value error because as you see here, list dot remove x, which is good, which is our syntax. X not in list. What does it mean by x not in list? So x is the value, right? So x is the value here. So 50 is not present in the list. So if you try to remove an element which is not in your list, you are going to raise an value error. All right. So jumping to our next functionality, what is the difference between remove and pop? So earlier we saw that remove just removes the element at the very first occurrence of an element. In pop method, it is a built-in function, but it removes an element from a list at a specified index position. Okay, and also it returns the value of the removed element. So talking about remove, you're not going to know which element was removed. So you're not going to get it as a separate object. But in pop, you get to have access to the elements because the pop function will return the value of the removed element. Talking about the key characteristics, it is an in-place modification. So the pop method modifies the original list by removing the element directly. It also returns the removed list. So you get to access the element which was removed from your original list. Similarly as remove, it raises an index error if the provided index is out of range or if the list is empty, and pop function is called without an index. So if you try to call your function without an index, or if you're trying to specify an index which is not part of your current list, you're going to get an index error with your pop function. So talking about its functionality, what happens, let's break it down. If an index is provided as an argument to pop function, it removes the element at that specified index from the list. So it just removes the element from that list, and also the position of your index, it gets altered as well. So if you remove an element from a particular position, whatever the elements onwards, okay, from that specified position, they are going to have get one index position lesser. For instance, your existing index position is 2, and if you remove an element from position 1, your new, the list, the element onward is going to get the value 1, because it is going to have an onward alteration. So let's talk about this use case scenario. I've got a list here with apple, banana, cherry, and date. Now what I want to do is I want to remove my element from the index position 1. So what is the index position 1 here? What is the element here? So you have 0, comma 1, comma 2, and 3. So based on this, my index 1 is banana. So if I try to remove it based on my index position 1, my element is going to be removed. Okay, it is going to be popped out. So banana is removed. So you can see here that I get an access to see my element which was removed. And because there is an in list modification, you can see that banana has been removed. Okay, let's say I don't provide it with index. What happens in this case is that the pop function will remove the last element by default. Okay, this is my current list, right? Apple, banana, and cherry. I'm trying to remove an element using pop function, but I'm not specifying an index. In this case, the last element by default gets popped out. So if I have a look at my current list, it is just having apple and banana. What did my original list have? Apple, banana, and cherry. But because I used pop function to remove it, it removed the last portion, which is cherry, and then I got a new list that doesn't include cherry, but just apple and banana. And to our next functionality, how to clear a list. So you have a list and now you want to clear it. How do you do it? A clear method is used to remove all elements from a list, effectively making it an empty list. No matter the size of your list, you can have an element like a single element to even a list with 1,000 elements. It doesn't matter. What happens is your clear method is going to remove all the elements from a list. And what happens when you remove all the elements? It becomes an empty list. So a clear list will make an empty list. And clear function is an in-list modification. So your original list get modified. Your original list gets altered. So you're not going to get a new list or an updated list, but rather your existing original list gets modified. And the modification here is you just clear all the elements from it. So breaking down its functionality, the purpose of a clear list is to make an empty list. Okay, so you are going to maintain the list object, which is a list. So let's say you create a my list is equal to 1 2 3. You're going to maintain the list object. Okay, you're going to have it, you're going to have the list object. So you're not deleting the my list. So from your memory, you're not removing the object itself, you're not removing the list object itself, but you're just emptying the list, the elements within the list object. So that's what is the purpose. That's the purpose of a clear function. And talking about syntax, the syntax is as similar as previous methods. So you specify a list name, you use a dot notation, and then you use a clear method which will clear all your elements from your list. It doesn't have any arguments to keep it up, so you just have to use clear method. It doesn't have any arguments or any parameters. And also the clear method does not return any value, it just modifies the list. Okay, so you're not going to get any new list or updated list, you're not going to return anything, but just an in place modification, which in our case is altering our existing list. So let's talk an example here. We have gotten my list. So my list is currently having 1 2 3 4 5 elements within a list. And what would happen if I try to run dot clear function? So what has happened here? Yes, this is my list, my original list, but my original list has come empty, as you see here. So, but is my list still present? Yes, you can check it. So if I print my list, yes, I'm getting an empty list. But what has happened? All the elements have been removed. So it is just removing the elements, but the list object itself, it exists. To our final question of the day, what is index method in list? So we have already seen about indexing, right? So your index starts from 0. So 0 1 2 3, the positional index goes further. But is it same to the index method? No, it is different. In index method, you get to access your element from that particular position. So what happens is, let's say you have an element. Okay, you have 10 elements in your list, and you have an element called apple. You want to know the index of that particular element. That is when you use an index function. So index method is different, indexing method is different. Okay, so indexing is where you get a number for the positional number for each of your elements, so that is indexing. And talking about index method, you specify the elements and your code gives you the elements at that particular positional index. Okay, by definition, the index method in Python list is a built-in function. All right, so it's a built-in function, as we know about it, and it is used to find the position or the first occurrence of a specified element within a list. So talking about our previous example where we had multiple same elements, for example apple, right? We had a repetition of element apple twice in our list. In that case, what happens is it just returns the index of the first occurrence of an element. So you get to have the position of an element, but if there are multiple elements that are getting repeated, you get the first occurrence of the element. So here it how it works. First, it searches for the given element from the start of your list. So you have a list, you specify type You specify to find the index of a particular element. You specify the element, and what happens is it goes from the first position. So 0, 1, 2, 3, 4, 5, 6. So it goes one by one. From the beginning of the list, it searches, and then it will return the lowest index at which the element is found. So whenever the particular element that you're looking for comes, the very first occurrence you're going to get as a positional index. And let's say you don't have that particular element in your list. In that case, you are going to raise a value error. What is a value error? Value error is where you don't have that particular value in your list. So if you specify a value that is not in your list, you're going to get an error called value error. Let's talk about the syntax. The syntax is you specify your list name, and then you use a dot notation to specify your index method, and it can take up to 3 arguments for your index function. And no matter what, even if you have 3 arguments, not everything is required by default. So only the element that you would like to find the index for is a necessary or a mandatory argument. So in the element section, you specify what element would you like to search for in the list. And then you have 2 optional parameters. Those are start and end. Let's say you have a list, okay? You have a list. Let's say this is your list. And you want to find the position of number 1. Okay, you want to find the position of element 1. But you don't want to include this element which is at the position 0. You don't want to include that, but you just want to start from, let's say this is the position you want to start from. So you want to access the index of an element just starting from this position. In that case, you have to position your start index. So what is your start index for this? So it's 0, 1, 2, and 3. So your start position is going to be 3, right? So in that case, you can specify 3 as your start element. And then end. So end is same as well. So let's say you want to find only if there is okay, let me put a 3 here. Okay, you have 3 in a 3 different position, but you have a scenario where you want to find only elements between this index. So you don't want the index of this, you don't want, you know to know the index of this element, but rather if there is element only between this positional index. So I have to specify the positional index of 4. So what is the start here? 0, 1, 2, and 3. So 3 is the start for my 4, and what is my end? 3, 4, 5, 6, 7. So 7 is my end position. So what I can do is I can specify 3 comma 7, which is my start and end of the element. So start is an integer specifying the starting index for the search, while the end is an integer specifying the ending index for the search. And in start, the search will begin from this index, and when you specify your end position, your search stops there. Okay, let's see with an example. I've got a list here which is having repeated values as well. So if I print it, you can see that it has got multiple repetitive elements. Okay, so apple, banana, cherry, banana, date, apple, banana, cherry, it's getting repeated, right? So these are my repeated elements, and now I want to find the index of banana. Okay, so what I'm trying to do here is I'm using my list, which is my list name. I'm using dot notation, I'm using index method, and I'm specifying the value. So in this context, I want to find the value of banana. So when I try to run it, it is giving me the position 1. And why not a different one? So if you consider this 0, 1, 2, 3, 4. So I have one more banana at 3. Why it didn't give? Because indexing helps you to find the first occurrence of your element. So banana is your first occurrence. So here you see that it has given you the positional index of your banana at your first occurrence, which is positional index 1. Okay. Let's say I want to find only the position of banana from the position 2. So 0, 1, 2. So I want to start from this position. How do I do that? So you specify your optional parameter. So here 2 is my optional parameter, right? So my list dot index, my elements value, so which is banana. Then I'm specifying my positional index too. So start from here. In that case, it is giving my index as 3. So no matter where you start, your positional index is going to be maintained. So 0, 1, 2, and 3. So if you even consider the full list, your index for banana is 3, right? So no matter where I start in my list, it is going to give me the position of the element banana, which is 3 if I consider whole of my list. Okay. So now what I want to do is I want to find the element grape. Okay. So what I'm trying to do here is I've created a new list: apple, banana, cherry, banana, and date, and I'm printing the list. As you can see here, my list is printed. Here is where it gets interesting. I want to remove the element grape, which is not present in my list. In this case, what would happen is you're going to get a value error, as I said earlier, right? So I'm trying to remove this element grape. As you can see here, the error says that grape is not in the list. So if you do this, you're going to get a value error. What do I mean by a value error? When a particular value is not present in the list and you specify it, you raise a value error. But there is a way you can handle this. Usually this try and accept is taught in your advanced lessons, but considering you trying for your interviews, I don't want to keep it in the advanced session, but I want you to get a regular practice. So hence I've included this try except block in this particular session. It's not an rocket science, it's very simple. Okay, what are you trying to do? Just imagine this. Okay, I'll remove this. You have got a try block. So this is your original code, right? You know how to write this code, right? It's your actual syntax. So you have your my list, you use your dot index, and then you specify your element. This is how your actual code works. And now with try except block, what you do is you just add a keyword try with a with a colon next to it. Okay, and then you specify except. So in exceptional circumstance, I want you to do this. That's what is meant by an error block. Sorry, an except block. So you already know that you usually get a value error, right? So what I'm trying to tell to my system is that except value error as E. So if there is going to be a value error, get it as E. So I'm giving an alias as E. Okay, except value error as E, and I want to print it. So same scenario, when I try to run this code, it gave me an error, right? So it is raising me a value error. So to avoid a value error, I can use and try except block, which is not going to have any error raised at all. So let's see how this works in our scenario. So if you see here, my code has run, but though there was an error, so grape is not present, an error was raised here. But if you consider this, though there is an error happening, which is a value error, it doesn't break out my code, right? In here you can see that my code has broken, but in here my code hasn't broken. So this is not an very important thing that you need to focus right at this moment, but I just want to place it here so that you get used to how to write your try and except blocks. So that is all for today. So I hope this session was very helpful to you. So what did we cover today? So just to give you a summary, we have seen that what is a list. So what is a list? List is an ordered mutable, and it could allow for your duplicates, and it's a important data structure within your Python. So it can have multiple types of data within your as a collectible in your Python. So what did we see about? So we learned how to create a list. So a list can have multiple mixed types, and then we saw a few built-in methods and functions. So you saw how to create a list. To a list, how do you add an element? You add an element using append. So you add your element to your end position. So how do you add all elements of a list? So instead of as a single item, how do you add them as an individual element? You use an extend functionality. Okay, how do you add an element to your fixed position? You use insert to add an element to your specified position. And how do you remove an element from the list? You remove an element from the list using a remove functionality. And then how does a pop differ to your remove? It differs in a way that you use index position to specify which element to be removed from that particular index position. But if you don't specify the index position, the last element usually gets popped out. And you learned how to clear a list. So when you use clear function, your list object exists, but all its elements get removed out. What is a index method in list? So when you try to find the index of a particular element, you specify the value, and therefore you get your index of that particular element. All right, so that is all for today. Thanks for watching this video. I hope this video was very useful to you. So if you like this content, do like the video. Feel free to ask your questions in the comment section. Feel free to share it with your fellow friends who are aspiring to be a Python developer, data engineer, irrelevant of your role. If for their role, if Python is playing a crucial part for them, share it with them. Let them learn as much as you do. And then uh, like the click on the bell button so that you don't miss on the updates as well. So do check on our other regional language channels as well. So we have multiple channels in Tamil, Telugu, and English as well. So this is our English channel. So make sure you have a look on it. So that is all for today. So we have our headquarters in India. We have 3 centers in India, and we recently launched one more center at Hyderabad as well. And our other headquarters are in USA and United Kingdom as well. So feel free to check out our website, which is DATAVALLEY-INC. So you will find different streams of subjects you know getting taught. So which includes like data science, data engineering, data analyst, ethical hacking, MERN stack. So we teach multiple domains. So feel free to check it out. And I hope this session was very useful to you. Stay tuned for further session. So until then, this is Franklin signing off. Thank you so much, and I wish you all a good luck with your interview. And I hope you have a good day. Thank you so much. Bye bye. Take care.